they have a very useful combinatorics trick that we'll go over with this problem. Pat wants to buy 4 donuts from an ample supply of 3 types of donuts: glazed, chocolate, powdered. How many different selections are possible? So we want 4 donuts, and we want to split it in some way into those 3 categories. Another way we can say that is to split these 4 donuts into 3 groupings by putting dividers in between that represent each of the cases. So in this case, this is the glazed group, this is the chocolate group, and this is the powdered group. And we have 1 glazed, 2 chocolate, and 1 powdered. Another possible way we could do it is by putting this here and here, in which case we have 0 glazed, 4 chocolate, and 0 powdered. Or we could do this and say 2 glazed, 0 chocolate, and 2 powdered. But regardless, as long as we put 2 dividers somewhere, it will give you a unique variation. What that means is that if we have 4 donuts and then 2 slots for dividers, then we can put donuts wherever. The other 2 can be dividers. In this case, we have glazed, chocolate, powdered, 1 chocolate, 3 powdered. In this first case, we have the divider in the 2nd slot and the 5th slot. In this case, the 1st and the 6th. So this problem is essentially you have 6 spaces and you want to put dividers in 2. How many ways can you do that? And how many ways signifies combinatorics. Let's look at this problem. Since we have 3 different groups, we need 2 dividers. That way we can have the left group, middle group, and the right group. Okay, since we want 4 donuts and 2 dividers, that's 6 different slots. And where do we want to put the dividers? Well, we want to put it into 2 of the slots, so we choose 2. Now, let's recap some combinatorics. It's the same thing as saying 6 choose 2. How many ways can you choose 2 slots out of 6? Well, the first slot can be any of these 6. The second slot, after you pick 1 for the first slot, you have 5 slots left. There's 5. But if you can pick this first, then this, or you can pick this first, then this. So you count everything twice because you can flip the order that you choose. So you must divide by 2. This gives 15 as total combinations of donuts that you can buy. And just to recap, this formula also comes from the choose function formula, which states if we have n choose k, we have n factorial divided by k factorial multiplied by n minus k factorial. In this case, our n was the number of donuts, 4, plus 1 less than the number of groups. In this case, we had 3 types, so it was 2. 4 plus 2 is 6. And we wanted 2 dividers, k is 2. And so, simplifying that, we will come to this, and we will still get 15.